All right, ladies and gentlemen, this is going to be our next video on chemical reactions. So let's get started. So what is a chemical reaction? And some of you guys might be thinking of a mad scientist inside a laboratory going through and mixing all sorts of liquids and substances together to get large explosions. But a chemical reaction is really a process that involves the rearrangement of a molecular or ionic structure of a substance as opposed to a physical change. So again, we're not melting, we're not going through and boiling and going through different phase changes. We are going through and creating new arrangements of the molecular and ionic structures of substances. So let's delve into the types of chemical reactions to better understand this. Okay, so let's go through and look at a basic chemical reaction, and let's go through and discuss what occurs. So when we're talking about chemical reactions, we're talking about substances going through and changing their molecular structure to form new substances. On the case on the left, we have two hydrogen gas molecules and we have an oxygen gas molecule. Now we can go through and put energy in and change and rearrange this into two water molecules. So we have the same stuff. We had 4 hydrogens on the left-hand side, 2 oxygens on the left-hand side. We've gone through and rearranged them. We still have 4 on the right and 2 on the right, but now they're in a different molecular structure. So the way we would write this out is we would have 2H2 plus O2 is going to turn into, or is going to react to form 2H2O. Everything on the left we're going to call our reactants, and everything on the right we're going to call our products. So let's delve into what the numbers mean to better understand this. So when we're discussing the numbers, these big superscripts are going to refer to the specific or the quantity of molecules for this particular gas, in this case, that exists. So this 2 is referring to the 2 hydrogen gas molecules, which are here and here. And this 2 is referring to those 2 molecules. Now, this little subscript here is referring that in each of these molecules, there are 2 hydrogens. So let's look at oxygen. We can assume that since there's nothing in front of it, we're going to assume that there's just 1 oxygen here. Now this 2 is going to refer to 2 oxygen atoms making up our oxygen molecule here. If we look at the arrow, this arrow is saying that we're going through a chemical reaction. We have our reactants here, and now they're going through and turning into our products. Now this 2 is again referring to the 2 water molecules here, and this 2 here is referring that each water molecule has 2 hydrogens, and we can assume that since there's nothing here, this means that there's that there's 1 oxygen atom that makes up each of these water molecules. So we have our superscripts, we also have our subscripts, which are here, here, and here. And they both correspond to different things. These refer to the quantity of molecules, and these refer to the quantity of atoms that make up the specific molecules. Okay, so let's look at the types of chemical reactions that we're going to have to know for this particular course. So we have a synthesis reaction, we have a decomposition reaction, we have a combustion reaction, single replacement, and double replacement reactions. These are the 5 that we're going to delve into now. Okay, so during a synthesis reaction, a combination is made from simpler materials. So let's think about this. Let's say I have atom A and I add atom B. During a synthesis reaction, I'm going to go through, add energy, and I'm going to get a new molecule that is a combination of both A and B. So A has been placed here, B has been placed here, and we've synthesized or put these 2 atoms together to create our new molecule. So an example of this would be when we mix aluminum and iodine together to form aluminum iodide. And by going through and combining these 2 elements, what we get is a chemical reaction that forms 2 aluminum iodide. So another common example is photosynthesis. Photosynthesis is where we go through and create glucose, which later provides energy in the form of sugars for other living organisms. All right, during a decomposition reaction, this is when a compound is broken down into simpler compounds or all the way down to the elements that it's made of. So during a decomposition reaction, we're going to take a complex molecule. In this case, we have A and B that makes up the molecule. We go through, add energy, and go through a chemical reaction, and we separate this into its individual elements. So in this case, A and B are separated through a chemical reaction. So A is going to go here, B is going to go here, and we've broken it down into its simplest elements. Okay, so an example of this is when we go through and take hydrogen peroxide, add a catalyst, and convert it into oxygen and hydrogen gases. And we can see that chemical reaction occurring in the test tube and in the beaker here in the image. During a combustion reaction, we're going to have a compound containing carbon and hydrogen and sometimes oxygen, and we're going to combine oxygen gas to produce carbon dioxide and water. So our products are always going to be carbon dioxide and water, but our compound that we go through, our reactants that we mixed, are usually going to contain oxygen, but always contain carbon and hydrogen. So during a combustion reaction, we're going to get a flame. So let's say we have this carbon, and I'm just putting an X subscript here to represent that it could be any size. And we have this added with a hydrogen. And again, I'm going to put a subscript here to represent any quantity of hydrogens and carbons present. We add oxygen or oxygen gas, which is O2, which I'm representing here, and we go through a chemical reaction. And what we get is we're going to get carbon dioxide and water. So during combustion, we always get carbon dioxide and water, but it requires carbon, hydrogen, and oxygen gas molecules to go through this combustion reaction. Okay, so during a single replacement reaction, it's going to be a little more complicated. So let's say the yellow dinosaur and the blue dinosaur are two elements that are melded together or bonded together to create a molecule. We also have a red dinosaur here to represent another atom. Now, during a single replacement, one element that starts out by itself replaces another element in a compound, kicking it out. So let's go through. We're going to add energy, and we're going to go through a chemical reaction. Now, the yellow dinosaur used to be bound to the blue dinosaur, but now the blue dinosaur went through and it moved over and went through and bonded with the red dinosaur. So the yellow dinosaur was kicked out. And again, we're pretending this is an atom here. And what we had was a switch in which elements were bound with which elements. This is a single replacement reaction. Now, an example of a single replacement reaction is when we go through and take copper and silver nitrate and react them together. And what we form is a crystalline structure that allows us to go through and see these crystals form along the copper. And it's going to turn a very dark blue or almost like a navy or ice blue color here. We can see as we speed up this image, you can see the crystals going through and forming on this particular copper wire. Now, a double replacement reaction gets a little more complicated. So we have all of the unicorns here. And again, we're pretending that they are, in this case, atoms or ions. Let's pretend that they were ions and they're existing ionically bonded to each other. Now, what's going to happen in a double replacement reaction is positive and negative ions in two compounds switch places. So we have the purple and we have the pink unicorn that are bonded together, and we have the green and the blue unicorn that are bonded together. Now these ions are going to switch places, so now the pink unicorn is bonded to the green unicorn, and now the blue unicorn is bonded to the purple unicorn. This is a double replacement reaction, and this is the most complicated reaction that we've really gone through and talked about. Okay, so let's go through and talk about the law of conservation of mass. Now, the law of conservation of mass says that energy and mass cannot be created nor destroyed. They can only be transferred. So the universe is essentially a closed system. All of the energy that has ever existed in the universe is still here. We've just gone through transformations. And all of the mass that has ever existed in the universe is still here. It just changes shape and turns into different stuff. So we rearrange all of these elements to form different molecules, but essentially it's all the same stuff that's ever existed. So let's take a look at two systems here and their transformation. So right now on the left, I have 18 oxygen, 12 hydrogen, and I have 6 carbon. I'm going to go through a chemical reaction, adding energy, and I'm going to go through and rearrange all of those atoms. Now I've rearranged those atoms into, in this case, water and carbon dioxide molecules. Well, let's look at it. On the left, I had 18 oxygen, 6 carbon, and 12 hydrogen. On the right, again, I still have the same 18 oxygen, 6 carbon, and 12 hydrogen. All I've done is gone through a chemical reaction, added energy, and now I've rearranged them into different things. This is the law of conservation of mass. Mass cannot be created nor destroyed. We can change its shape and rearrange it, though. And energy cannot be created nor destroyed. It can only be transferred or go through and change into different forms. Now, rearranging all of this stuff requires energy. And what we can do is we can go through and extract the energy out of each of these molecules when we go through and rearrange them. So let's look at the carbon dioxide that we went through and rearranged from the left to the right through a chemical reaction. Well, when we go through and break the bonds of these carbon dioxide from the carbon and the 2 oxygens that exist in this carbon dioxide molecule, we can release that energy that we put in. And this is what we refer to as chemical energy. We put energy in to rearrange those molecules, and then we've released that energy by breaking those bonds. So, did you guys learn? Well, a couple of things. Did you guys learn what a chemical reaction is, the types of chemical reactions, and the law of conservation of mass? This is all I have for you guys right now. I will see you guys in class on Monday.